Just imagine looking up at the night sky and seeing not just stars, but entire islands of billions of suns, each a galaxy in its own right. What if these faint smudges are actually our closest cosmic neighbors, locked in a gravitational dance that spans millions of light years? In this episode, we're stepping beyond our own galaxy to explore the incredible architecture of our galactic neighborhood. When we lift our eyes beyond the veil of the Milky Way, we see faint smudges scattered across darkness, patches of light that are not stars, but entire galaxies. They are our neighbors on the grandest scale. Each carries within it hundreds of billions of suns, and yet between them stretches nearly empty space so immense that even light takes millions of years to cross. To explore this realm is to step from the scale of the familiar toward the architecture of the universe. The Milky Way does not wander alone. It belongs to a local group, a gravitational family of more than 80 galaxies bound together by their mutual attraction. From its hub to its outskirts, this group spans roughly 10 million light-years, a bubble of space drifting through the cosmic void. Within it reside three principal members: the Milky Way, the Andromeda Galaxy, Messier 31, and the smaller Triangulum Galaxy, Messier 33. The rest are dwarf galaxies, tiny satellites that orbit the larger giants like sparks encircling flames. The Andromeda Galaxy, the largest of our neighbors, lies about 2.54 million light-years away in the northern constellation of the same name. Even to the naked eye on a clear night, it appears as a faint oval mist, visible without a telescope, the most distant object routinely seen by human eyes. Through modern instruments, it becomes a majestic spiral nearly 220,000 light-years across, more than twice the diameter of the Milky Way, home to perhaps 1 trillion stars. In Andromeda, we glimpse not alienness but familiarity. Spiral arms rich with star-forming regions, a bright nucleus, and a halo threaded with ancient globular clusters. It is, in essence, a grand sibling of our own galaxy. For billions of years, Andromeda and the Milky Way have drifted slowly toward each other, drawn inexorably by gravity. Their mutual approach speed, about 110 kilometers per second, will bring them into collision in roughly 4.3 billion years. When they meet, neither galaxy will shatter like solid objects. Instead, they will pass through one another, their stars so widely separated that almost none will collide, yet gravity will warp their shapes, flinging long tidal tails and streams of stars across space. After several passes, the pair will merge into a single elliptical galaxy, often nicknamed Milkomeda. For any civilization existing then, the night sky will ignite with new suns and brilliant arcs, a spectacle 2 galaxies wide. If you're captivated by the cosmic dance of galaxies, consider hitting that subscribe button and joining us for more explorations into the universe's grand designs. The Triangulum Galaxy, the third major member of our local group, lies 2.7 million light-years away. It is a smaller spiral with graceful symmetry, about half the Milky Way's diameter. Its subtle spiral arms are studded with regions of intense star formation, including NGC 604, one of the largest known stellar nurseries. Triangulum may be an orbiting companion of Andromeda, and if so, it will likely join the dance of their eventual merger. 3 spirals, ours, Andromeda, and Triangulum, form the backbone of the local group's structure, dominating its gravitational balance. Surrounding these giants swarm dozens of dwarf galaxies, small systems containing anywhere from a few million to a few 100 million stars. Faint and irregular, they are the fossils of the early universe, building blocks from which larger galaxies formed. 2 of the brightest are visible from the southern hemisphere, the large and small Magellanic Clouds, easily seen as wisps below the southern Milky Way. These are tidally distorted companions orbiting our galaxy roughly 160 and 200,000 light-years away. Gas streams drawn from them form the Magellanic Bridge and the lengthy Magellanic Stream, arcs of hydrogen stretching halfway around the sky. They are living evidence of the gravitational choreography still unfolding between galaxies. Other satellites are much smaller and subtler: Sagittarius Dwarf, Sculptor, Fornax, Leo 1 and 2, Draco, and more recently discovered ultra-faint dwarfs found by surveys such as the Dark Energy Survey. Most are spheroidal swarms of ancient stars, bare of gas, relics slowly being absorbed into the Milky Way's halo. Their motions trace the invisible web of dark matter that governs our group's collective behavior. At its heart, the local group resembles a loose double system, two great spirals separated by 2.5 million light-years, each orbited by its own satellites, together revolving around a shared center of mass somewhere between them. Beyond about 5 million light-years, the gravitational influence of larger cosmic structures takes over. Other nearby groups, those of M81, IC 342, and Centaurus A, form neighboring clusters. All these are themselves drawn toward the gravitational domain of the Virgo cluster, 30 million light-years away, the nearest major concentration of galaxies. But if our local group is just a small family of galaxies, what happens when these families come together? What colossal structures emerge when gravity pulls not just stars, but entire galaxies into a dance that spans hundreds of millions of light-years, revealing the true cosmic web of the universe? The gravitational hierarchy continues upward. Dozens of galaxy groups, including ours, form the Virgo supercluster, a vast region about 110 million light-years across, containing more than 100 galaxy clusters. Recent surveys refined our view further. The Virgo supercluster is part of an even grander structure known as the Laniakea supercluster, Hawaiian for immeasurable heaven. Spanning nearly 500 million light-years, Laniakea contains roughly 100,000 galaxies, all flowing along gravitational streams toward a convergence zone called the Great Attractor in the direction of the constellations Centaurus and Norma. Within that cosmic basin, our own local group is a minor tributary drifting alongside countless others. Galaxies across Laniakea move not through empty space but along filaments shaped by dark matter and the expanding fabric of the universe itself. The arrangement resembles a coral reef or a neural network, filaments of galaxies connected by knots of clusters, with vast voids stretching between. This cosmic web is the large-scale structure of the universe, the pattern in which all matter is arranged. Although we think of our galaxy as still, it, too, travels extraordinary distances. Relative to the cosmic microwave background, the faint radiation left from the Big Bang, the Milky Way is moving at about 627 kilometers per second toward the constellation Leo. Our local group's gravitational interactions with Virgo, Centaurus A, and the Great Attractor combine into a complex drift through space-time. In cosmic terms, motion never ceases. What changes is only the frame from which we measure it. To visualize this motion, imagine the cosmic web as a flowing ocean where galaxies are the currents. Each group like ours moves inward along its filament toward deeper gravitational wells, while the entire fabric of space expands, carrying everything apart on larger scales. Local gravity binds groups and clusters, but beyond those bounds, cosmic expansion dominates. Space itself stretches so that distant galaxies recede faster than light, not because they move through space faster than C, but because the space between us expands. Revealing this vast pattern has been one of humanity's greatest cartographic achievements. Beginning with the Sloan Digital Sky Survey in the 2000s, astronomers mapped the positions and redshifts of millions of galaxies, constructing three-dimensional models of the nearby universe. More recent efforts, such as the Dark Energy Spectroscopic Instrument and the Euclid mission launched by the European Space Agency, continue this work, charting galactic flows up to 10 billion light-years away. Each dot on these cosmic maps represents not a star, but an entire galaxy of stars, each separated from its neighbors by voids tens of millions of light-years wide. Because light takes time to travel, these maps are also records of history. Looking at nearby galaxies shows the present. Looking farther back shows earlier epochs when galaxies were younger, smaller, and closer together. In this way, the universe reveals both space and time simultaneously. The local group is simply our momentary address in a structure still evolving over billions of years. What lies ahead for this galactic family? Over the next few billion years, the Milky Way, Andromeda, and Triangulum will merge into one elliptical titan. Many of the dwarf satellites will be absorbed, others may be flung into intergalactic exile. As the merged galaxy stabilizes, its stars will continue to orbit a common center, gradually dimming as star formation wanes. Beyond that, expansion will stretch the universe further, carrying distant galaxies beyond our event horizon. Eons in the future, only the merged remnant and its local companions will remain visible to any observers, our cosmic neighborhood retreating into its own island universe. This coming isolation does not diminish the significance of what surrounds us now. For a brief window in cosmic time, these few tens of millions of years, our instruments can still see far enough to trace the filaments and clusters beyond. We live in the golden age of observation, when the sky still contains evidence of ancient connections soon to vanish beyond the observable limit. From our vantage, the local group embodies the balance between gravity and expansion. Within 10 million light-years, gravity rules. Beyond that, cosmic expansion prevails. Between these realms lies the threshold where local motion yields to universal drift. Our group is therefore a microcosm of cosmic architecture, a knot of matter resisting the tide for a time, held together by its own mass, while the rest of the cosmos accelerates away. The diversity of galaxies within it, spirals, ellipticals, irregular dwarfs, also mirrors the stages of galactic evolution itself. Spirals, alive with new stars, represent youth and vitality. Ellipticals, older and redder, mark settled adulthood. The dwarfs, mixed hues and shapes, remind us of cosmic infancy. All coexist within one gravitational family, just as their stars span every imaginable form of matter and age. To speak of millions or billions of light-years is to confront numbers that dwarf comprehension, yet those same numbers weave us into belonging. Our atoms trace lineage not only to ancient stars, but to earlier galaxies merged into the Milky Way long before Earth existed. The calcium in your bones, the iron in your blood, likely originated in supernovae of long-absorbed progenitor galaxies billions of years ago. In that sense, the local group is family history written in starlight. When we stand under the night sky, we are participating in that lineage. Every photon from Andromeda or the Magellanic Clouds crosses space patiently for millions of years before brushing the retina. To see such light is to complete its journey. You, the observer, are the final coordinate in a voyage that began before humanity evolved. Awareness itself becomes part of the cosmic exchange, and so our galactic neighborhood is not simply a collection of distant suns, but a community of histories merging through gravity and time. Each galaxy's path bends subtly toward another. Each encounter reshapes what follows. The pattern is endless, recursive, and magnificent, a local tapestry within the infinite quilt of the universe. In the next episode, we will step yet farther outward, from groups and clusters to the cosmic web itself, the lattice of filaments and voids that frame the entirety of the visible universe, showing how matter, energy, and dark matter together define the ultimate shape of all that exists. If you've enjoyed exploring our galactic neighborhood, make sure to subscribe for more incredible journeys through the cosmos. And to continue your exploration of the universe's wonders, Click on the video appearing on your screen right now.